Hi, I'm Andy Gupp, and I'm here with my colleague Allison Davis, and we have a fun-packed tech session for you today on building apps for Angular with the ArcGIS API for JavaScript. We have a full schedule of topics for you. We're going to primarily be looking at patterns related to the Angular CLI. We're going to cover two different ways to load the ArcGIS API for JavaScript modules within your application. The first one is going to be Esri Loader, and the second one that I'm going to close out the session today with will be working with Webpack. We'll look at major topics related to async patterns, the CDK for Angular. We'll talk about using services and routing, and perhaps most importantly, we'll talk a little bit about using state management to manage your app within a larger Angular application. Just a few housekeeping items before we get started. This session is about Angular 6+, and more specifically, it's about Angular 9. The repo that this session is based on at github.com/Esri, Angular CLI Esri map, we typically only address issues based on the latest production version of Angular, which at this stage is Angular 9. The good news is if you're using Angular 8, that it's similar enough to Angular 9 that we'll also be able to address those questions effectively. Also to keep in mind that this is for version 4 of the ArcGIS API for JavaScript. If you're using the version 3, then you'll need to upgrade to version 4 before using these patterns. The patterns that we're showing in the tech session today will not work with version 3. And last but not least, if you're using AngularJS, also known as Angular version 1, again, you'll also have to upgrade before using the patterns that we show here. This will be good information for you to have in your back pocket, but the information will not be usable. The patterns will not be repeatable within AngularJS. Before we get started, I have a few items to orient you to where we are so that you can not only follow along, but also get started if you're just new to Angular or new to our JavaScript API. The primary repo for these sessions is shown here, and I'll pause so that you can freeze on that and look it up and set your browser to that. We recommend digging through the repo so that you can follow along during this tech session, as well as having access to it as a resource after the tech session. So let's take a quick look at that repo. There's two folders as well as a README that talks about how to get started. The slides are in the docs folder. The real meat of the repo, all of the sample and example applications that we're showing today are available in the sample apps folder. Everything that we're doing today, all the source code is available there, and it's a much deeper dive than what you'll get through the online SDK. And again, this builds on the Angular CLI Esri map repo. All the source code is here for your viewing pleasure. If you're new to Angular or new to our JavaScript API, at developers.arcgis.com/JavaScript, under the guide topic is some very high level getting started information on installation and configuration so you can get going before you dig into the content of this tech session. And lastly, before I hand this over, I want to familiarize you with some of the app scaffolding. These are just some of the basic patterns inside the repo that we'll be repeating over and over again as important concepts so that you can get started quickly and easily with the ArcGIS API for JavaScript. So let me flip over to Visual Studio Code, and I am in the app scaffolding repo. that's inside the sample apps directory. And just wanted to point out a few things. In package.json, you can either npm install Esri Loader or manually add it to your package.json. The types, the ArcGIS API types, are optional and not required, but we do recommend them as a best practice, and you can either npm install those or manually add them to your package.json. And another pattern that we recommend is in your CSS or your Sass is where you want to import your JavaScript API CSS, as well as any other CSS related to the mapping component, to ensure that the CSS is consistently loaded in a way that looks correct to the end user during the life cycle of the application. And last but not least is you'll see this pattern repeated throughout the next several demos in your main mapping component. And almost all of these repos under sample apps do have a mapping component to modularize that functionality, to see how the mapping component more easily interplays with the other aspects of parent components or other components that you have within your application. And you're also going to see this pattern, importing the load modules method, as well as just the last note that I'm going to make is you'll see us referring to the types namespace just as a simple variable. Makes our code look cleaner, and that's all we're doing, is just making it look a little bit more appealing, since you have to look at it all the time versus just using the standard namespace. So with that, I'll turn it back over to Allison. Allison, take it away.
Alrighty, so I'm going to talk in a little bit more detail about Esri Loader. Esri Loader is a small open source library that allows you to lazily load ArcGIS modules, which are in AMD format, into any JavaScript application, no matter what framework or tooling you're using. So you can lazy loading is set up by default. If for some reason you don't want to use the lazy loading in your application, you can also use a static script tag. So check out the Esri Loader docs for more information on how to set that up. Esri Loader works with the JavaScript API, either 3.x or 4.x. All of our demos, though, are going to be using the 4.x JavaScript API. And the nice thing is, even if you're not writing Angular applications, Esri Loader works with any loader, bundler, framework config. And it does integrate really nicely with the Angular CLI right out of the box. So you don't have to worry too much about trying to customize anything to get this working. So here's an example of what this would look like in code. So we're just importing that load modules from Esri Loader, and that dynamically injects a script tag onto the page. And then you can use either a promise-based pattern or you can use async await. So if you're using a promise, you call load modules and you pass an array of the modules that you're using in your application. And then once that has resolved, then any ArcGIS JavaScript code that you're writing would go inside of that function call there. You could also, if you're using async await, then you can just set up an async function and then await that load modules call with that same array of the modules you're using. So either of those patterns works super well. And another tool available for you to use in your applications is types for ArcGIS JS API. So TypeScript is, as you probably know, a typed superset of JavaScript that compiles to plain JavaScript. And there's a lot of benefits that TypeScript brings to the table into your code. Using types means cleaner code and fewer errors. We also get IntelliSense in our IDEs. It makes working with, for example, complicated API responses or large data objects a lot simpler to kind of define the shape of the data that we're working with on our application. It really helps your JavaScript scale really well. So TypeScript is used by Angular as a primary language for app development. And Esri, in turn, provides type definitions for the ArcGIS API for JavaScript, which you can install using npm or your package manager. And so it really, really helps when you're working with the JS API to have access to those immediately in your code. So I'm not going to go into too much detail there because TypeScript configuration and working with TypeScript could be a whole nother session almost. But if you want to check out additional resources, Esri has a TypeScript setup guide linked below, and Angular also has a lot of really great resources around digging into TypeScript configuration in your applications. We also have a sample app that shows kind of the base configuration for working with the ArcGIS JS types in an Angular CLI app that's linked in the title of this slide. So check that out. Next, I'm going to talk a little bit about async operations in your Angular applications. And there are certainly other patterns for managing async and out of sequence operations, but these are three big ones that you'll see a lot. The first is promises. Then we have custom events in Angular, and finally RxJS and observables. So first, we're going to take a look at promises demo application. I'm going to pop over here. I'm running this demo locally. And you can access all of this code in the GitHub repo if you'd like to follow along, or you can run it on your own machine later. So here we have our demo app. We have a select menu and then a map here, and we can select a world wonder, and then our map will pan to that landmark. And as you see, each time we select a different value in that select menu, first we see a little panning message that panning is in process, and then we see a done message flash on the screen. And you also might have noticed that the select menu is disabled while the panning is taking place. I'll show that again. So I'm going to show you a little bit of what's going on in the code. So inside of our Angular app, we have a couple of different components that we're working with. We have a parent dashboard component, and then we have a child Esri map component that we're using. And so here in our dashboard parent, let's scroll down just a little bit, we're using view child so that we have an instance of that Esri map component here, and we're setting an instance of that to the variable map. And then a little bit further below, you see this selected wonder function. Now in our dashboard template, here's our select in HTML, and we're just on the input event, we're just calling that selected wonder function in our component here. And that in turn, so when a change or an input value occurs inside our select menu, then the select wonder function is run, and that in turn calls this.map.panmap. So it's accessing that child component and then calling the panmap function. Panmap, if we pop over to our Esri map component, actually returns a promise. And so when that promise resolves, it's zooming to a level of the map. The set timeout is occurring just so that we can see a more exaggerated result when we run this demo application. Without the set timeouts, the actual function calls go way quicker, so it's harder to see when you're playing around with this demo, so that's why that's there. So back in dashboard, so selected wonder is called. First, the panel is disabled, so that select is just completely disabled. We call panmap, and then once we have our promise resolved, then we call enable panel, and then we see that feedback message of done, and then we can select another world wonder and do another pan call. And again, you'll see another set timeout here. Again, that's just to make the demo a little bit more legible as we're stepping through and playing around with this code. So next we're going to take a look at a pretty similar demo, but using Angular custom events and the event emitter to manage our async operations. So let's pop over to the browser again. So we see a similar demo. We see the same select. We select a world wonder. Our map is panning. And then again, we see a done call. And then our menu is again re-enabled. So the functionality here is quite similar to our last demo, but let's take a look at the code and we'll look at some key differences there. So inside of our application code, we again have a parent dashboard and then a child Esri map component. We're again using viewChild to have a reference to an instance of that child component in our code with the variable map. And then if we scroll down a little bit, we see again our selected wonder function. But what's going on under the hood is a little bit different. So first things first, let's take a look at our dashboard components template. And again, we've got that event binding to the DOM event of input, and that's what's calling that selected wonder function. Now, if we go over to Esri map, we see that same pan map function, but we also have an instance of an event emitter. And so what we're doing here is creating a custom event emitter called Wonder Mapped. And what's happening is we've got the same pan map functionality. We're zooming in and going to our coordinates. And then once our promise is resolved, then we're calling this dot emit. And so that is a method that's on this instance of the event emitter. So we're emitting this event. And then what happens is actually the child component emits this event to the parent. So if we go back to our dashboard template, and here is our instance of the child component, we see that we have actually bound to this Wonder Mapped event, and then we're calling enable panel. So back in our dashboard component, this is kind of the order of things. So the input from our dashboard component changes, selected wonder is called, first the panel is disabled, then we're calling this dot map, so that's the instance of our child component dot pan map. Pan map in our child component actually emits that custom event, and then when the parent receives that event that's emitted from the child, it calls the enable panel function, which is defined down here. And that's what is re-enabling our select. And we also see that feedback message of done. And again, we've just got those set timeout functions kind of sprinkled throughout the code just to make the order of operations a little clearer and a little easier to see as we're stepping through this demo in the browser. So our final async pattern that we're going to be taking a look at is observables and RxJS. So observables are used heavily within Angular for lots of different common async operations, HTTP requests, reactive forms, routing, and actually under the hood, Angular custom events. So the event emitters that we were just looking at in our last demo, that's actually an extension of the RxJS subject. So if you want to learn more about observables and their usage within the Angular framework, you can check out the Angular docs linked here. They have a lot of really great information about kind of how and why they're using that paradigm. RxJS is a library for reactive programming that provides an implementation of observables and utility functions for working with observables and creating them. RxJS is necessary in order to use observables in JavaScript until it becomes part of the language and browsers support it whenever that might be. In the meantime, you have to use RxJS in order to use this programming paradigm. And so observables, in a little bit more detail, so they provide support for passing messages between publishers and subscribers in application code. And so observables are declarative, meaning you define a function that publishes values, but that function isn't actually executed unless you have a consumer subscribing to it. And then once it's subscribed, a consumer then receives notifications until one of two things happens. Either the function completes and therefore ends the process, or if the consumer unsubscribes, then that also would end the stream. So you declare the function, but it's only actually running, and the consumer is only actually receiving values if subscribed. And observables can deliver multiple values of any type. And the really nice thing about observables is that the observable itself handles setup and teardown. So all your application code needs to do is to subscribe in order to consume values, and then whenever it's done, unsubscribe. And that doesn't matter whether the stream of data being received is keystrokes as a user is typing into an input box, response from an HTTP request, or an interval timer, the process looks exactly the same. And so basically, as an example, we can see here in the demo we're about to look at, we have a subscription defined here. We subscribe to these value changes. In this case, these are the value changes observable that is created when we're using reactive forms. We subscribe to that, and then whenever a change takes place, we take that value and then we can write code to handle that value however we like. It's really important when you're working with subscriptions in your components, though, in ng on destroy in your component lifecycle to unsubscribe to any subscriptions that you may have done earlier in your component lifecycle. And that's really important for avoiding memory leaks and just maximizing performance in your application. So we're going to take a look at the same demo, looking at the world wonders, but this time we're going to be using observables in a couple of different ways, both within a service, and so with how we're receiving data, and then also through the reactive forms module that Angular provides to us. So the functionality, again, is pretty similar. You'll see we select Great Wall of China. We have our panning message. The panning animation takes place. And then once the pan operation is complete and we zoom in, you'll see that done message. And then once again, the input is re-enabled. Now, the other thing that we have here is thanks to the reactive forms module, we can actually log out some information about our form and what's happening to it at different points in the application. So for example, we can say that so far the form has not been touched since this component has been reinitialized. The form value is currently set to 0 because that's the first value in our list of inputs here. If we change it to Petra, you see our form value changes to 1. Great. And then you'll also notice that when that form is disabled, form valid is actually set to false. And then when it actually has a value, once everything is re-enabled, you see that it's set back to true. So let's take a look at the code and see what's actually going on under the hood. So in this demo, the first thing that we're going to be doing is creating a service that components in our application can actually subscribe to within their own code. So Andy's going to talk a little bit more about services in detail, but for now, we're just importing a subject from RxJS, and we're creating a couple of different subjects, a pan request and then a pan complete. And then here, you see that we're also setting our list of wonder landmarks here. And then in the pan to wonder function, we have the coordinates that are getting passed in. We're setting those and then calling the next function within that subject. So what this looks like, if we go over to our control panel, You see in here, we have a couple of subscriptions in the ng on init function. So that's in our component lifecycle when our component initializes. And the first thing that we're doing is we're subscribing to this pan complete observable that's set by our map service. And then when any changes come through from that subscription, then we're calling the enable panel function. And you'll see up above, as in our other examples, that just means that we're re-enabling that form and we're setting that feedback message to done. So that flashes once the pan is complete. And then over in our map component, go over here. So what we're doing here is we're actually, we have our map service inside of our constructor here. And then inside of this pan map function, we're going to our specified coordinates. And then just as before, we're setting that zoom level to 18. And then on complete, we're calling this map service pan to wonder complete. So letting the service know that that pan logic is completed. And then we also have a subscription here so that the pan request is subscribed to. And then whenever changes come through, then we're calling this.pan map and handing off the coordinates to that. The other thing that we're doing in the control panel component is that we're also we're using form control, which is from the Angular Reactive Forms module, to create so that we can get some of the benefits of that reactive form module. So if we pop over here, you'll see that we set Wonder Form to a new instance of form control. And here in the constructor, you can pass in an initial value if you like, and there are also some options that you can check out in the Angular docs that you can also use. For right now, we're just setting up a new empty form control. And then over in our control panel template, you'll see here we're setting this select the form control input to equal wonder form, which is the name of the form control that we just initialized. The rest of this code is the same. And then here down below, these are where we're logging out that form information that we can get from our form control. So all of these are properties of the form control. So if the user has touched the control, if the value of the form is valid, and then the value itself. So not just what's appearing here in the element, but the actual value attribute. We can log all of those out. That's really handy for debugging. And also we can do a lot of really cool things with form validation when we're using reactive forms and custom validators. So back in our control component down here, so we have our Wonder Form subscription, and value changes is something that's provided to us by the Reactive Form module. And so we can actually subscribe to any value changes in the form. And then if any changes take place in that control, then we actually have this value wonder, and then we can do something with that value. And so here, we're saying that if at any time the value changes, we want to disable that panel. We call our pan to wonder function. And then because we're subscribed to that pan complete observable, that's when enable panel is called and taken care of here. And then as you can see in the ng on destroy part of the component lifecycle, we're unsubscribing from both of those. RxJS also provides a lot of great operators for doing things like combining observables, only taking the first emitted value from an observable and then automatically unsubscribing. There are a lot of really cool ways that you can work with streams of data and observables in your applications. So those are the three different async patterns that we're going to cover. And As I was saying earlier, the links to all of these demos are available in the slide titles. There's a demo for each pattern. So check those out on our GitHub repo. You can pull those down and run locally and play around with those. And then we've also tried to link to different points in the Angular documentation that talks a little bit more about where these patterns crop up when you're using this framework. So next I want to talk a little bit about the Angular Component Developer Kit, or CDK. And this is a library authored by the Angular team. And this is a really great resource if you're working with custom components and UI. And what it does is that it implements common interaction patterns and components, some of which are quite complicated. So things like portals or like different kinds of drop downs, different kinds of accessibility behavior, a lot of the really complicated and quite technical pieces of UI component development that can get really challenging and really bog down developers if you're trying to create things from scratch. And the great thing about the developer kit is that it's also totally unopinionated about how you present these components. Basically, everything is unstyled. These things really, really lend themselves well to working as a foundation and then having you build your actual component design on top of that and styling it yourself. And Angular Material, which you may have worked with before, which is the material design library of components for Angular, is actually built on top of the CDK. So the CDK is kind of the basic foundation unstyled, and then Angular Material is built on top of that. So for example, we pop over to the Angular Material docs, we have things like portals and stuff like that, or scrolling, and then styled components within Angular Material are actually built on top of these foundations. So everything is very high quality. Everything is maintained by teams that are part of the Angular and Google teams. So the quality is very, very high. And it's a really great resource for getting complicated components and pieces of UI going in your applications. So this is where you'll find documentation on the CDK here. And we're going to look at a simple demo where we're bringing in the data table component, which the documentation you'll find right here. And this is an unopinionated data table component, and it's got a really great API. And we're going to bring a simple version of that into an application demo, building off of the demos we've been doing with our async operations. Jump back here. And so the other nice thing about using the CDK components is you have access to accessibility and responsiveness. They work right outside of the box. So if we jump to our demo and I resize the browser, you'll see that my table is actually automatically shrinking as the size of the window changes. And that's handled by the CDK. I didn't make any changes in my component to account for that. So that's really, really nice to not have to deal with that. And then also developers have full control over the functionality. So it's really easy to create your own custom styles, things like sorting and pagination. You really can add that on top. One kind of note of caution, if you're looking for something that's a little bit more ready to go out of the box, I would recommend working with Angular Material and not the CDK. This is definitely designed more for developers that don't want to implement kind of the base behavior, but at the same time, they want to have a lot of say over how they style things, how their UI interactions work. Building your own sorting, pagination, et cetera, those features have to be added on top. The other nice thing is that the template of this table and our data source, they exist completely independently of each other. And I'll show you how that works in code in just a second. So going back to our demo here. And all that's happening here, we have a table and we're citing an ID for each wonder of the world. We have a name and our coordinates here. And if I click on one of these rows, you'll see that same pan and zooming functionality that's has been occurring in our other demos, and then there we are. So next I'm going to crack open our editor here and we can talk about a little bit about what's going on under the hood. So inside of this demo, the first thing I just want to call attention to is the table component that we've built. So we're bringing in a couple of things. The data source, this is from the CDK. We're going to use that to create an instance of a data source to connect to our table. We're bringing in the Esri map service that's pretty similar to what we constructed in the last demo. And then we're also bringing in behavior subject and observable from RxJS. And if we scroll down a little bit, the first thing that we're doing is just setting up a Wonder interface to create the shape of our data, if you will. So we're setting property of ID, which is a number, name, which is a string, and then coordinates, which is an array of numbers. And then for right now, we're just hard coding our data set here as Wonder data. And as you can see, each object in this array follows that Wonder interface. And then a little bit further down, so inside of our table component, we are injecting an instance of map service. And then we're creating a reference to data source. So we create the class test data source a little bit further below, and that's where we're actually setting what data we're going to be using in the table. And then we also have this handle click function, which is actually handling the logic of what happens when a table row gets clicked on. And then below here, we have the data source class. So this is returning a behavior subject or data property rather, is an instance of behavior subject, which in turn is an array of wonders. We're using that Wonder interface up above. And we're just passing as an argument that constant Wonder data that we defined up above for the purposes of this demo. And then connect, so this gets called under the hood actually by our CDK table, and we're just returning this data. So this is something that the data table can hook onto and subscribe to. And then in our template, the first thing that we do here inside of our table, and you'll see these directives all over the place. This is how the CDK actually defines tables, table cells, table rows as part of the CDK table. Using these directives. And then we have an input of data source that we're setting to the data source that we defined in our component. And then inside of each of these instances of ng container, we're setting a header cell, and then we're also setting the actual column definition. So each of these we're hooking into a different property of an instance of Wonder. So here we have wonder.id, wonder.name, and then here we're manipulating that a little bit. So in our data set, we just had an array of coordinates, and here we're actually displaying those Wonder coordinates at index 0 and then at index 1 to display that x and y coordinates. And you'll notice here we're setting these header cells, and the names will display on our data. And you can also, there's a similar directive CDK footer cell where you can do the same thing. And then here we have our header row, and that's where, if we pop back to our table, we have an array of displayed columns. So we're displaying each of the columns. Now, you can change these and hide or show columns. So if you have multiple instances of a table, that could be useful. But for right now, we're just doing all of our displayed columns, which are all the columns we've defined. And then here, we actually have those row definitions, and then we're iterating over each of those Now, in the table row is where you can actually do things like add event listeners. So we have added a click handler where we're calling that handle click function. You can also do some really cool things with conditional styling that's based on the data in your table. For example, if we wanted to highlight all of our world wonders that were in a certain range of coordinates, we could do that. If we had additional data fields, say the continent where each world wonder was located. We could do some conditional styling in that way. So it's really nice because even though the table and the data are existing independently of one another, we can also rely on that template to do some really cool conditionals with the data that we're bringing in. So that handle click function is over here in our table, and we're just calling that same pan to wonder function from our map service and just passing that the array of coordinates from the row. So that is a relatively quick introduction to the Angular CDK. And now I'm going to pass things back to Andy, and he's going to talk a little bit more about using services as well as state management in Angular applications.
Thanks, Allison. Now I'm going to talk about Angular state management. And there's many different aspects to state within an Angular application, including the application state, the component state, the shared state, the router state. But really what we're focused on here in the examples I'm going to be showing is the state of the map component. And there's many, many different choices for how you go about doing this. And there's no wrong answers. It depends on your requirements, it depends on your skill sets, and it depends on the capabilities of these different libraries such as RxJS, RxJS plus Redux, NgRx, NGSX, and Angular Redux, and the list goes on. I'm going to be showing just two examples. I'm going to be showing a simple store just using plain old RxJS, as well as an NgRx data store, which is a lot more scalable solution. So the first sample that I want to show, again, is just very simple map state, and I just need to maintain this state between routes. And I'm going to use a service to do this built on RxJS. So here's my application, and it consists of three different components. I have the header component with a viewport that's empty right now. I have my mapping component, which is here, and in another tab, I just have a different route that shows a different component just to show the example of navigating away and coming back. And the idea behind this is a couple of things. One, to set the stage for my next demo is to show you when the user navigates away from this, notice the island is on the left side of the map. I'm going to navigate away, and then I'm going to come back. The map reconstitutes to its default. And that's okay for the purposes of this application right here. What this application is really designed to do is when the user clicks on the map, like this, I want to be able to preserve those points when the user comes back to the mapping component. So I'm going to navigate away, and then I'm going to come back, and when my map reconstitutes, the points are still there. And I also want to share this data in the header component. I want to share these latitude, longitudes, so that as soon as the user clicks, that viewport is automatically updated with those points. So there's a few things going on related to maintaining state in this application. So let's go ahead and take a look at the code. The key part behind this is using RxJS observables and behavior subjects in my service. And behind the scenes is just a very generic map store that's as decoupled as possible. When I say generic, it's completely decoupled from the service in as many ways as possible so that it has complete flexibility with how the service or other services access it. So in this case, it just does three things. It lets me get the value from the behavior subject. It lets me get the state as an observable, and it also lets me set the state using a behavior subject. And that's it. That is all this data store does, and it's just storing an array of lat long. So it's very simple. So let's go ahead and look at the service that's accessing the store. And here I have my map store service, and it lets me do two things. It lets me get the points, so I can retrieve the set of latitude longitudes that are stored within that array, and it lets me add an individual point. So that's it. That's all the service does. In this case, I want to point out one more thing, is that the map store does need an initial value. So in the super method of the constructor, you'll notice I'm just passing an empty array, and there's multiple purposes for that. So let's go take a look at my map component and see how we use this service. So in the ng-on-init, when the map view is initialized, so this is when I navigate away and come back, this is not for when the application is restarted. This is just during a single user session. When the map is ready, I'm going to subscribe to the service. I'm going to retrieve those points, that array, in this case it's Esri graphics that I'm storing, and if there are any available, so remember I just passed an empty array in the super of my service. If the empty array returns, I'm not going to do anything when the map first loads. If there is values in the array, I'm going to go ahead and add those to the graphics layer in my map, and then I'm going to simply unsubscribe, and I'm done. That's all I need to do, is when the user navigates away, comes back, if there's points of graphics that need to be re-added to the map, I do that, and then I can unsubscribe, and I'm done. In terms of the workflow where the user is adding points on a click, with each click I create a new graphic. I add those graphics to the graphics layer, and within my service I'm using the add point method to simply add that graphic to my store. That's it. So let's take a look at the header component. The header component's a little bit different. It's subscribing to the service continuously so that if the user does click on a map, I can populate that viewport. So in this case, I'm doing something a little bit different. Now I'm still subscribing to my service through the get points method, but I'm also detaching change detection. Now this is something that typically you just want to use the default settings and update the UI at about 16 to 17 milliseconds. In this case, the user isn't clicking on the map very often, and I only want to update the user interface when the user clicks on the map. So whenever there is a next value in my service, I go ahead and process the latitude longitude. I pass it to an observable, and then I force change detection on the UI to update the user interface. So let's take a look at the HTML for this header component. So I'm using a CDK virtual scroll viewport. I'm simply implementing the CDK virtual for to iterate on my pMessage observable. And what I do is anytime there's an update, I'm going to iterate through that array in pMessage and display it in the header. And that's it. That is my example of a very simple store. It's just storing an array of latitude longitudes. When the user navigates away from my mapping component and comes back, that data is restored, and I'm sharing that data through a service into another component. Now let's take a look at a much more scalable approach to maintaining application state. And this example uses an NgRx data store. And a picture is worth 1,000 words. Let's just go ahead and take a look at the application. This is very similar to the simple map state application, except it addresses one specific item that I pointed out that is a deficiency in the simple map state app. Here, I want to be able to save the state of the map, its zoom level and center, when the user moves away from the map, navigates to another component, and comes back. So I'll show you here that I've changed the zoom level and center. I can go on a different route, navigate back to my map, and it's reconstituted in exactly the same place. Now, just to be clear, this is during the user session. This is not storing offline state in the sense that I could close the browser tab and come back and expect to have it restored. This is just within a single session that I want to preserve the state of the map. So let's take a look at the code. So here I am inside the data store folder on the repo, and we're going to take a look at how I built this state. It's all stored in all the different pieces of it are stored within the state subfolder. Let's first take a look at index.ts, which is essentially loads all the different aspects of my data store. And here I have two different aspects. I have a create selector, which lets me select the map state, as you can see here. And I also have a reducer, which lets me create something actionable against my data store. So let's take a look at the reducers. There's a couple different aspects to this. I have a reducer here to set the map state. That's where I'm going to change the data store. And literally, when I run the set map state method, it's going to change that value within the data store. It's just going to add it directly to the data store. And I also have a select map state, not to be confused with set. This is select, that's going to either return an initial state if my store hasn't been set up before, or the current state of the map. So let's take a look at the initial state. I've created an entity adapter that defines the default values for the state within my application. And I have a zoom level of 12 here, and I have a serialized string for the object that represents the map view's center. So I have one model, and that's my map settings. It simply contains zoom as a number and center as a string, as I mentioned before. I'm doing that for serialization purposes. I can set it as a string and deserialize it as JSON to use it directly within my mapping component. I also have one action, the set map state. I use the create action method. And as you can see, this is part of NgRx data store, as I've set in my imports here. And when I want to set the map state, it's very simple. I set a props property. I set props based on a map property, and in it is just my map settings object, and that's it. So let's take a look at how that works within the mapping component. And I'll just start at the top and work my way down. This is all used internally within the component. I don't have any connection to the user interface here, just to make that clear. This is just updating the mapping component and how the map works when it's reconstituted, when the user navigates away and then comes back. So at the heart of this is a map state observable variable and a static map state variable, which is just a snapshot of my observable. So I'll show you how that works. In my constructor, I'm importing my store, And I set the observable up based on a store pipe. And what that pipe's doing is using my select map selector. I know that's a mouthful, but that pipe's calling the select map selector and essentially injecting that into my map state observable. So in ng on init, I go ahead and subscribe to that observable, which is my store. And every time my store is updated through next, I create a new snapshot using static map state. So every time my store is updated, I want to capture that information in my local store. I'm sorry, in the application store. So let's go down to map view. When the application is first loaded, I'm going to use that select map state to set the center and zoom. So to do that, as I mentioned before, I have to basically deserialize it. So I JSON parse my string and set the center property on my map view. I take the static map state zoom and set my map view zoom property. So now when my map loads, it's going to set up the store. It's going to subscribe to the observable. If there's any information in it, it's either going to grab the initial state or the current state, and it's going to set that on my map view. And so when the map view is reloaded, all of that information will be available and it will be returned to the previous state that the user left it. So the way that I'm updating the state when the map navigates around is I'm setting a watcher on the extent property. So once the map is loaded, mapView.when, I set this watcher, and within that, I have a function that runs a debouncer. So as the user navigates, the extent property is fired a lot. There is a lot of extent changes that come with that, and we want to settle that down a bit in the debouncer and try and minimize the number of times that we're calling store.dispatch on that to set the map state. So we run this through the debouncer, which is calming things down. There's a lot of events firing. I create a new map settings object, and I use the store.dispatch function to set the map state. That is the only way that I can change the state within my store. That's the only way that I can do it. And that's it. That's a very simple but very scalable example of how to maintain a simple map state on the map as the user navigates around, and to return to that state when the user navigates away and then comes back. So for the next section, I'll talk about using Webpack with the ArcGIS API for JavaScript. All right, so let's talk about Angular and the ArcGIS Webpack plugin. All the code in this section is available in the Angular CLI Esri repo under the ArcGIS Webpack Angular branch. So if you go to the repo at github.com/Esri and you select the ArcGIS Webpack Angular branch, all the code is here, including a README that provides some basic instructions on how to get started with this. Some key things to know. This only works with Angular 8 and Angular 9, and it only works with the ArcGIS API for JavaScript version 4.7 plus only. And you will have to configure Webpack using builders. You can't eject Webpack anymore in the latest versions of Angular. And builders provide delegate functions for doing things like linting and testing and, of course, building. And the one that I'm using for this example is a custom library that helps with that. You can build your own, and I don't recommend it. So I use Angular Builder's custom Webpack library. So if we go ahead and open that up and just take a quick look, the latest version was just published a few days ago for Angular 9, and it's available on NPM. Now, once you've installed this, there are some configuration things that you need to do in order to get it to work right, but it's really straightforward. In your Angular JSON, under the build task, you're going to change the builder path to represent Angular Builder's custom Webpack and set that to browser. And you're also going to specify a custom Webpack config file, which we'll talk about next. And you also want to set up your new path for serving. Just something to be aware of, that if you don't set those, things aren't going to work quite right. You will create a Webpack config file in the root of your application or wherever you want to put it. And this is where you import the ArcGIS Webpack plugin. You can see here that we're bringing it in through a require statement. And then there's just some basic module exports that you need to set. I'll call attention to setting FS to empty off the bat. That's a good place to start. Could eliminate some troubleshooting and some compile time errors when you go to initially launch your application. So that's just something to pay attention to that might save you some time and head scratching later. Once it's installed and you go ahead and build your application, everything on the inside of the application is going to look different than what we've talked about before when you're using Esri Loader. Now, if you're using the Webpack plugin, you can use this pattern just like this. So standard ESM imports are the way to go and the word of the day when you're using the Webpack plugin. Pretty cool, right? Just simply say import map from the path name to the module, and boom, you are done. So in ng on a init, in this particular application, it's going to look just like you would expect it to, except now you're newing up the class name exactly as you would expect it in a plain old JavaScript application without the need to use Esri Loader, without the need to import your own require statements. Now all that's being handled behind the scenes for you. It's still there, but within your application, you can use standard import statements. Just a word, if you're working with secure services and you start seeing worker, global, scope, errors, something to the effect of what you see here, then there's a couple additional steps that you need to take. I've provided a handy link here so that you can look at this information yourself. Is you want to import Esri config, just like here at the top of your application, and then an ng on a init. Before you run your application code, you're going to copy and paste this block of code in there to handle how workers are used within the JavaScript API. Of course, you want to change this to the latest version, which is currently 4.14. We hope this is just a temporary solution. In the long term, we are aiming for pure ESM compliance, but for now, if you run into these errors, that is the way to go to solve them. Of course, if you have any other issues, any other problems, feel free to open an issue on the Angular CLI Esri map repo, and we'll do our best to take care of you. And that's it. That brings us to the end of our presentation. We covered a ton of things related to using the ArcGIS API for JavaScript and Angular, from Esri Loader to Async and CDKs and maintaining state and a lot of other cool things that we talked about. And we hope that you found this super useful. We've provided a bunch of additional resource links at the back of the reveal deck. I guess that's going to be converted into a PDF for you that you can click through to get access to these. The presentation GitHub repo, references to the guide topics, Esri Loader, ArcGIS Webpack plugin, and much, much more. Those resources are just available right here for you. And on behalf of Allison and myself, we thank you for tuning in for the session. We hope that this helps you get started quickly And as always, feel free to reach out on github.com/the issues there if you have additional questions. Thank you very much.